So this lesson is over the first 2 pages of your notes, so it should go pretty quickly. The unit that we're on right now is the Introduction to Atomic Theory, and nuclear chemistry is also going to be covered at the same time. So it's going to be quite a bit of information in a really short amount of time. So it's going to be very important to keep up with everything and not put everything off because, like I said, we're going to move through it pretty quick in a very short amount of time. So let's get started. So we're going to talk first about how we went from the philosophical ideas to a scientific theory. So first we need to talk about the 3 basic laws that describe how matter behaves in a chemical reaction. The first one is one that you are familiar with, and that is the law of conservation of mass. And it states that mass is neither created nor destroyed during an ordinary chemical reaction or during physical changes. So what that means for us is if I start with a certain amount of mass, I need to end with that same amount of mass. It also means if I start a reaction and I started with 4 carbon and 6 hydrogen, I need to end with 4 carbon and 6 hydrogen. They may just be rearranged during a chemical reaction, but the mass itself or the matter is conserved. So let's move on to the next law. So the law of definite proportions states that a chemical compound contains the same elements in exactly the same proportions by mass, regardless of the size of sample or the source of sample. So I give the example here of table salt, which is 39.34% sodium and 60.66% chlorine by mass, and that's no matter where the sample is found, whether I have 5 grams of it or 5,000 tons of it. The sodium itself is made up of 39% sodium and a little over 60% chlorine, no matter where it's found, and that goes the same for every chemical compound. And so you need to make sure you know that for a test, because that, anytime we talk about laws, you better know it's probably going to show up on a test. So the last law we're going to talk about here is the law of multiple proportions, and it states that if 2 or more compounds are composed of the same 2 elements, then the ratio of the masses of the second element combined with the certain mass of the first element is always a ratio. So this is just like kind of a confusing way to say that although we know that based on the law of definite composition that they do so in a fixed ratio, there are some elements that can combine to form a various number of compounds. But when they do so, they still do it in a fixed ratio. And the example here is carbon and oxygen. They can combine to form CO, and then they also can combine to form CO2 right here. So they can form those 2 compounds. And so they have the ability to form those different 2 compounds, but every time that they form CO, it will be in a fixed ratio, and every time they form CO2, also in its own fixed ratio. Another example is nitrogen and oxygen. It can form, oh gosh, oops, that's still highlighter, sorry about that. It can form like into O4, in O2, we can just do NO, it can do into O5. There is a variety of compounds that it can form, and so those are good examples of the law of multiple proportions. So a very big part of atomic theory and what we understand has to do with John Dalton's atomic theory. What he did was he proposed an explanation that encompassed all the 3 laws that we just talked about, and so he came up with his atomic theory, which has 5 postulates that we're going to talk about on the next slide. But make sure you know that it's John Dalton or Dalton's atomic theory for a test. So here we go with his atomic theory. The first thing he said was that all matter is composed of extremely small particles called atoms. Secondly, he said that atoms of the same element are exactly the same. And that means they're exactly the same in size, mass, and other properties. And then he said atoms of different elements differ in size, mass, and other properties. And while we're here, I want you to go ahead and put a star by number 2, and I'll explain why in a minute. And then he said that atoms cannot be, in postulate number 3, atoms cannot be subdivided, created, or destroyed. So I also want you to put a star by that, and again, I'll explain why in a minute. And then the 4th postulate says atoms of different elements combine in simple whole number ratios. to form chemical compounds. And then the last one says, in chemical reactions, atoms are combined, separated, or rearranged. Now, the reason I had you star number 2 and 3 is because now that we know more, those two components of his atomic theory have been modified. And let's talk about that when we go to the next slide. So the reason that 2 and 3 have been changed is for the following reasons. Postulate number 2 has been changed because we know about isotopes now. And what isotopes are, which we'll learn about in class, they are atoms that have different number of neutrons. And so because they have a different number of neutrons, they have different masses. And so that makes number 2 no longer valid, or at least it's been modified. And then number 3 has also been modified, or what basically we know more now, that we actually can subdivide atoms, and that is into subatomic particles of protons, neutrons, and electrons. So you would need to know in a test the two things of Dalton's atomic theory that have been changed. All right, so let's talk about the parts of the atom. So some of the early models, the first one was a Greek philosopher by the name of Democritus, and it was around 400 BC, and he came up with the idea that matter was composed of tiny particles that he called atomos, which was Greek for indivisible, and of course that's where we derived the word atom from. However, his teacher was Aristotle. I'm sure you've heard of him, and he disagreed with Democritus. And he, because he was the teacher and they didn't believe the student, it was Aristotle's idea that was believed for about 2,000 years before they ever revisited Democritus' theory. So really one of the first big discoveries about the atom was J.J. Thomson, and he discovered the electron with the cathode ray tube experiment, which you will get more into later. He also had the plum pudding model, which helped to predict the proton, and that was due to the fact that they knew that atoms were electrically neutral. And so since the electrons were negative, something in there had to be positive to balance that out. And he also proposed that since the electrons had such a small mass, is composed to the size of the atom, that there must be other particles to account for the atom's mass since the electron was so small. And so those were the first two big discoveries, and then in the next slide we'll talk about some other ones. So Rutherford, who was a student of Thomson, discovered the nucleus, and he did this by what's called the gold foil experiment. It's kind of famous in chemistry, and what he did was he bombarded a gold foil with positive alpha particles, which were basically helium nuclei, and this led to the nuclear model, which he proposed as being a small, dense, positive region, which contains most of the atom's mass, but takes up very little space. So how he discovered this was he was passing the alpha particles through the gold foil, and he expected most of them to go passing through, but some of them were deflected, and they were deflected in a very powerful way, and so they figured something's got to be in the middle of those atoms, which was causing the alpha particles to be deflected, okay? And of course, alpha particles are positive, and so it hit the nucleus, which is positively charged, and of course, they repel each other, like repels each other, and so that's how they discovered it. And so, of course, we know that from our studies of science and probably junior high and even younger, that the atoms is the smallest particle of an element that retains the chemical properties of that element. All atoms consist of two regions, the nucleus, and surrounding the nucleus is the electron cloud. So the proton is the first thing we're going to talk about, and of course we know that a proton is positively charged and it's located in the nucleus. The number of protons cannot change for an element. The number of protons always remain the same, and so that's actually how we will identify elements, is by its number of protons. The symbol for the proton is a little p with the plus sign. Of course, the charge of a proton is 1 plus, and then the mass of a proton is 1.673 times 10 to the negative 24 grams. Just to give you an idea of that mass, a paper clip weighs about a gram, okay? Maybe a little over a gram. And so that kind of tells you how small the mass of a proton is. However, it is still like over 1,800 times greater than an electron's mass. So a proton has a much larger mass compared to an electron's. And then on the next slide, we'll talk about the neutron. And neutrons, they're high energy, neutrally charged particles that are also located in the nucleus. And the actual number of neutrons can change for an element. We call those isotopes, which we'll be talking about in class. And the neutrons are in the nucleus, and they help to stabilize the nucleus by nuclear forces. And what nuclear forces are short range. They're either proton to neutron, they can be proton to proton, or they could be neutron to neutron forces that hold the nuclear particles together. And the nuclear particles, of course, are the ones that are inside the nucleus. The symbol for a neutron is a little n with the O because it's neutral, which is its charge of 0. And you can see by looking at the mass that it is pretty much the same as a proton's mass. Again, they're both much, much heavier than an electron's mass. So the electron is negatively charged, and it's located in the electron cloud. The number of electrons can change for an element. We call those ions, and that's if they gain or lose. And the electrons are actually what's going to be responsible for chemical reactivity. It's actually what forms the bonds with other elements, and we'll see that when we get later on into the year. The symbol for an electron is an E with a negative sign. The charge is a -1, and you can see that its mass, 9.11 times 10 to the negative 28, is much, much lighter than that of the proton and the neutron. So to wrap up, we just want to make sure that you understand that the nucleus contains most of the mass of the atom. Remember, it is small and densely packed. And then the electron cloud contains most of the volume of the atom. So I want you to remember that an atom is mostly empty space with a very small, densely packed nucleus in the middle. And most of the mass comes from the nucleus, most of the volume comes from the electron cloud. So if you'll stay tuned on the next slide, I will end this lesson with some corny jokes. So let's have some fun with periodic table humor. The first one is, do you know what the medical elements are? They are helium, curium, and barium, because if the doctor can't helium or curium, he buries them. How about what you call a goofy convict? He's a silicon. All right, see you in class.